So today we will cover atoms and molecules. Okay. So if you remember in the previous class, I'm going to review this again. Biological hierarchy. We started with basic atoms, and these are like carbon, hydrogen, oxygen, nitrogen, and so on. So they can combine to make molecules. Okay, so that can be H2O, CO2, and so on. Okay. So we are going to see today how these are combining to make the molecule and why do they combine and what type of processes are involved. Then these will make monomers. So these are called the building blocks to make polymers like amino acid. So this is an example of a monomer. And that would make a polymer. So the polymer can be a protein. So this is an example is of a polymer. And that would make parts of a cell. And this can be like a membrane. And so that is what is going to make a living cell. This is where the life is formed. This is what calls a unit of life. Okay. So this is the beginning of how living organisms start to exist. The rest of the hierarchy can go cells make tissue and organ system, organism. It's a higher level, but this is the beginning. How do they do that? That's a question we're asking. Okay. If you look at the simple structure of an atom, it's a unit of matter. That's what is atom. And matter is something that takes up space and has a mass. So you have, let's take an example of hydrogen, which has nothing but one proton in the nucleus and one electron. That's your hydrogen. Simple. And go to helium. It has in the nucleus two proton, two neutron, and two electrons. Okay, so I'm just refreshing chemistry. There's nothing complex here. Okay, very basic stuff you're starting with. And all of you know the proton is a positive charge. And this is one atomic mass unit. And electron, as you know, has a negative charge. It has 1,000th of an AMU. So it doesn't literally have any mass. And neutron has no charge, and this has one AMU. And this AMU is also called as Dalton. This is another unit, and this is also, you can measure that as a Dalton. Okay. So you need to understand how the properties of nucleus affects, and so these are the orbits or the shell. So this is like an electron cloud model, also an orbital model you need to understand. So higher the orbit, more energy they have, lower the orbit, less energy they have. So this is, again, if you want to understand the nature of the atomic particles and where the energy is coming from, okay? So the the next thing to understand is the thing called as octet rule. Okay, so this works for most of these elements in the periodic table. And this states that an atom with 2 electrons in the first shell or 8 electrons in the second or higher orbits tend to be stable and inert. Okay, so these are, you call as the noble gases, where they are complete in their shell. And the another thing that you want to understand is the valence orbit is the outermost orbit. Okay, so based on that, you can call us a valence electron. As orbits get full, they go to the next orbit. So as you can tell, the first orbit has this 2 electron, and the second orbit has 8 electron. So you would find 2 in the spherical orbit, and you would find 2 in the elliptical orbit going like this, and another one like going vertical like this. That's another 2 more, but I'm going to put them over here. And so there's another one going into the paper. This is what I call as a XYZ. So you have one can be vertical, one horizontal, one going into the paper. That's how 2 in each of them, and a spherical makes 8 electrons. That's the maximum they can hold. Once they are complete, they don't want to bother with anyone. But if they're not complete, they may try to make it complete by making bonds with other atoms. That's something important to understand. And the next one is electronegativity. So this is another concept you want to understand. So this is nothing but relative affinity of an atom. And we are not covering the full chemistry. We are just covering the basic chemistry knowledge you need to understand biology and biochemistry. Okay. For electrons, the relative affinity of an atom for electrons. Okay. So if you look at that, the most electronegative will be like fluorine, and on the left side, you can say chlorine, and then oxygen, nitrogen, then carbon, and the least will be like hydrogen, sodium, like that. They are the least electronegative. That's a relative scale is all you need to know. You don't need to know the number. Okay.
I have a question.
Sure.
Where it says an atom with 2 electrons in the first shell, what's
Yeah,
that?
if we have only one shell, this is like helium is an example. That is the first shell. That is complete. Helium is inert. It won't react with anything else. Okay. Hydrogen is not like that. It has only one. So it wants to make a bond with another hydrogen to complete it.
Okay. And with the octet rule, what is?
The second orbit can have 8. A second, third, fourth, all that can have 8. How can they have 8? One pair, which is going spherical, another pair horizontal, and another pair vertical, and the third pair going into the paper, XYZ angle. So that is 6 of them, plus 2 spherical is 8 maximum. Okay. So they need space to spin, right?
Yes.
Orbit is not like a shell, like an eggshell. It is a probable place where you can find the electrons, 99% probability. And like Earth's orbit, there's no track or a highway for Earth to travel around sun, just like that. Electron orbit is like that. And you can also think of it like an electron cloud model. But in this biology, we like the shell model more, easier to explain the processes. So we use that shell model. But even in the shell, all these XYZ is creating a cloud. It makes sense?
It did. Thank you.
Okay, welcome. And this is important concept to understand. To understand biological molecules, we talk about water being a polar molecule, CO2 being a non-polar molecule, O2 is a non-polar, H2 is a non-polar. The polarity of the molecule come from this, both octet rule and electronegativity. Okay. Everyone good? And few other terminology let's look at is isotope contains same number of protons. So that means the same element is what determined by the proton, and varying number of neutrons. Varying number of neutrons. So that is where you have the carbon 12 and the carbon 13 and the carbon 14. So you have the protons are going to be 6, 6, 6, and the neutrons are going to be 6, 7, 8. That's how the carbon 14 and carbon 12 vary from each other. So you want to understand where the isotopes are coming from, okay? Ions are positively or negatively charged atoms. Atoms are molecules. Okay, so let's look at examples. So atoms, this can be a calcium ion, a sodium ion, a chloride ion. All these are atoms. Molecules can be an amino acid that can be charged, okay? Or nucleic acid that can be charged. So that's all the negative and positively charged. Okay, so you need to understand the basic terminology in chemistry. Everybody good so far? Any question up to this point? And I'm not expecting you to memorize electronegativity number or anything. If I need you to understand, I will give you the periodic table. You don't need to memorize the periodic table unless you want to. But everybody good on this term so far? Any questions? Okay, good. Let's start the next one. So I'm going to go to how do they make the different bonds and interactions. So this is the second part. So chemical bonds and interactions. Okay. So the first of this is called as a covalent bond. The covalent bond is coupled valence electrons is where the name covalent bonds come from. What is this coupled valence electrons? So these are sharing of valence electrons between two atoms. Okay, so that's where this is coming from. let's take an example of a hydrogen and a hydrogen. So each of them have one proton in the middle and one electron. So they share this electron as a pair. So this pair of electron will spin around both of these and completing their valence shell, creating this H2 molecule. So this is what is H2. And you can also write like this. So this is same as how they make the bond. This is how you show the covalent bond. Okay. And another example of a covalent bond is between oxygen and hydrogen. So this is the hydrogen here, and that has one pair of electrons, and it has a one proton here. So this has electrons in the middle, two of them, and this has 4 electrons outside, and it's about 6. And in addition to that, they share a pair of electron in the valence shell. So this is 6 pair of electron, and they are shared with this oxygen, but you shared with this hydrogen. So if you look at this, there's another way of drawing this water molecule, which is H2O. And so here, this is called Lewis dot structure. There are 2 electrons are being shared with the hydrogen, and there are 2 pairs of electrons that are not shared with the hydrogen. Okay, these are unpaired electrons. So this is by itself that creates a partial negative charge to oxygen. And hydrogen being weak in electronegativity, oxygen is strong in electronegativity. The electrons spin around oxygen more. It results in a partial positive charge. Okay. So this is unpaired electrons creating more negative around the oxygen. So this type of bonding is called as a polar covalent bond. Polar covalent bond. Whereas H2 or the same thing will go to oxygen. Let me draw here O2, and you will have a bond like this. You have oxygen here. They have 6 pairs of electrons, and you will see 2 electrons here, like 4 of them. And then 2 pairs of electrons, they are being shared in the middle, and they have 2 electrons in the nucleus. This is oxygen, and they have 2 pairs of electrons being shared. That's why they have a double bond. Okay, so both of these are considered as a non-polar covalent bonds because there's no polarity. Polarity is having a negative positive distribution, uneven distribution of electron. What is uneven electron distribution causes the polarity. So everyone understand this covalent bond, polar and non-polar.
Yes.
Okay, good, excellent. So think, even though I'm using all this Lewis dot structure, everything, initially it may be kind of an overwhelming if you're not familiar with chemistry, but as you read more, it's not that complicated. So whenever you see a solid line, that represents a covalent bond. The next type of bond is an ionic bond. An ionic bond is where electron from a weakly electronegative atom. And in chemistry, you also call this between a metal and a non-metal. negative atom is gained by a strongly electronegative atom. And the example we see here, they are not sharing anything. They're just grabbing from another one, okay? So you have this sodium is a weakly electronegative. It has 1 electron in the valence shell. And chlorine, on the other hand, has 7 electron in the valence shell. So this has 7 electron in the valence shell. And so this needs to gain 7 electron to become complete, whereas this one needs only 1 electron to become complete. So after this electron moves to this has an 8 electrons in the next orbit. So this become a sodium ion and chloride ion plus a chloride ion. Okay, so this gains, or you loses an electron, so you have an extra proton. That is what is called as a positive charge. And the chlorine now become chloride ion, that is a negative charge. So you call this as a cation. This is negatively charged, is called as an anion. That's where the ionic bond is formed. So the attraction between these two, let me make it an attraction. That is what is called as an ionic bond. You will see positive sign, negative sign. In the polar covalent, you wouldn't notice it. You need to know an uneven distribution of electron causes this, and also the shape of the molecule causes that. Okay. The next type of bond is a hydrogen bond, where partially positive or partially negative. So this is a water molecule. This is attracting another hydrogen. This is a partially positive attracted to the partially negative. And the same thing, this is attracting another hydrogen. This will be attracted by an oxygen. And the solid line indicates a covalent bond. The dotted line indicates a hydrogen bond. Okay, so hydrogen bond is formed. Hydrogen bond is the attraction of hydrogen. Okay. Towards an electronegative atom. Electronegative atom. So in this case, oxygen is electronegative atom, and the hydrogen that is covalently bonded to one electronegative atom is attracted by another electronegative atom. Okay. So in this case, you need what do you call a need a polar, let me correct it, polar covalent bond with hydrogen. A non-polar covalent bond will not have this hydrogen bond. Okay, so it needs a polar covalent bond with the hydrogen. So this can also happen. The example will be between water and water, or ammonia, NH3. They can have this because they can create partially negative one, partially positive one. Okay. Then a couple more, then we wrap it up. So hydrophilic and hydrophobic. So in chemistry, when you read this, they will call everything as a dipole attraction. A negative, positive, that's a dipole. Positive, negative here. This is a dipole. So dipole attraction is what they call as, hydrophilic, hydrogen, and so on. So hydrophilic is polar molecules tend to be hydrophilic. They attract water molecule because water is polar, and non-polar molecule like O2, CO2, they tend to be hydrophobic. So they can make bond with water or no bond with water. That's all it is. Even though we try to call water loving and water hating, which is not appropriate. They don't love or hate anybody or anything. They make bonds or don't make bonds. That's what hydrophilic and hydrophobic is. Why they make bond? Because they are polar. Water is polar. And so this has a partial negative charge. This has a partial positive charge. There's a partial positive charge. This has a partial positive. See how they are attracted to that? This is how the bonding is happening between them. This is a partial negative charge attracting partial positive charge. Whereas in non-polar, there's no partial negative positive. It's not going to happen. Okay. The last but not the least is called van der Waals forces. So these are weak attractions. Weak attractions. Okay. Due to constantly moving electrons. So the electrons are not going to be in one place, they constantly move. So if the electron is on this side, so this tends to be a positive side. And there's another pair of electrons are spinning like this. The electron is here, it's a negative side, it's a positive side. That attraction between the electron cloud is what they call as the van der Waals forces. Okay. So that completes the lecture. So you have all these bonds and interactions, and learn from that. And so let's close this now.